Okay, pre-calculus, here's a warm-up in your packet, and I want you to look at these multiplication problems, and I want you to tell me what is underneath this question mark. So please write down this problem, but I want to know what number is under the question mark. I know that it's a multiplication problem, but a lot of people take 48, divide by 4. Survey says 12. Great job. Okay, here's another one. Please write down this problem. I need to know what is under the question mark. Most people don't know this answer off the top of their head. No, you're not allowed to use a calculator. I want you to figure out a way to get this factor. Okay, these are factors. These are factors. I know where this is going. It has something to do with this lesson, huh? So what I'm going to do is take 803 and I'm going to divide with some long division by 11. Now why don't you go ahead and do the long division. And don't forget to change. It's a nice number under that sticky note. Did you get the right answer? 73. Let's just refresh long division for everyone. You take a look at 11 and you compare it to 80. 11 goes into 87 times. After you find this number, you multiply it by 11. You multiply it and get 77. But then you have to subtract. You have to change the sign to the opposite. You have to change. That's going to be 3, and you drop down the 3. Then you compare 11 to 33, and it needs 3 more. 33, here comes the change again, and 0 is the remainder. If you get a remainder of 0, that means it divides in evenly, and so they're called factors. Okay, that's a nice little warm-up, getting us ready for some of the things we're going to do here today. Finding zeros of polynomials. So let's just kind of recap all the different things that we know. If you take a look at f of x, it's a 4th power. He's got lots of terms. How many real zeros does he have? I know people like to look at the power, but not necessarily that. The correct answer is at most 4. Maybe he has 4, maybe he only has 1 or 2. Maybe he has 0. How many complex zeros? Okay, whenever it says complex, that means real plus imaginary, so then it's exactly 4. Okay, if you have to use imaginaries, then you do it. So you can get it all the way down to 4 sets of parentheses, no matter what you need to use. All right, let's write this in factored form. First thing we do, PRZs. The factors of 18 are plus minus 1, 2, 3, 4 doesn't go in, but 6 does. Once you get to the matching set, you just bring it on home. 2 goes with 9, 1 goes with 18, and then we're going to divide these all by plus minus 1 and plus minus 3. So the PRZ list is plus minus 1, 2, 3, 6, 9, 18. Now let's divide them all by 3. 1 over 3, 2 over 3. 3 divided by 3, I already have 1. 6 over 3, I have 2. 9 over 3, I have it, and I have it. There's your PRZ list. Okay, so let's try. Do you guys want a hint? Alright, I tried 1 and negative 1 earlier, and they didn't work. And I tried 2, and he didn't work, so let's try negative 2. If you didn't have me and my lovely hints, you would just have to try these. So these did not work. Now we're on negative 2. What I highly recommend doing is starting on the left and working your way down the list. And on the test, I'm going to promise you that early on, you're going to find one of the PRZs early on. So it's not going to take you all the way to the end, okay? Little promise from me to you. 3, 5, 25, 45, negative 18. All right, I'm feeling lucky about this. 3, negative 6, negative 1, 2, 27, negative 54, negative 9, 18, winner, winner. As soon as you find a factor, let's write f of x in factored form. X plus 2, and it started off as a fourth power, so now I'm down to x cubed minus x squared plus 27x minus 9. Okay, now we can keep trying our PRZs, but people are starting to notice that, hey, if we can factor, let's just factor and get the job done here. So f of x equals x plus 2. And if you have to do some factor by grouping, then go ahead and find out those two factors for me. You might have to do some work, factor by grouping, use your brackets. And now we have 3x minus 1, okay? And then you should have gotten x squared plus 9. Does x squared plus 9 factor? Nope, it certainly does not. So I'm going to put a box around this answer, and I really want to make sure that you guys write down this note, okay? This one right here, this is factored. This is factored over the reals. If the directions on the test say factor over the reals, you're done. This is completely factored as far as I can go. But if we're allowed to use imaginaries, then we can do some work right here. Okay, so I'm going to take a look at x squared plus 9. I'm going to come over here and do some work. So x squared plus 9, I'm going to try to work with this, set it equal to 0. I move the 9 to the other side, that's negative 9. And I'm noticing here that when I'm square rooting, it's not working with reals, but that's okay if we're allowed to use imaginaries. So first of all, do not forget your plus minus. You got to poke an eye out. And radical 9 simplifies to 3. So the two factors are x equals 3i and x equals negative 3i. Okay, so you could solve it by hand, and if you need to use imaginaries, then you can. So let's write f of x again. Okay, don't forget your quantity x plus 2 from before, your 3x minus 1. Okay, and now I'm going to write x. Positive is going to be minus 3i, and the negative one is going to be plus 3i. So x to the fourth factored into 3 quantities if I was allowed to use reals. Okay, and I want you to write this note. This is factored. This is factored over the complex. Over the complex means using complex numbers. See how way to use imaginaries? So actually, let's go back up here and look at these questions. How many real zeros does he have? Okay, how many real zeros? Well, actually, now that I look at my factored form, he's got 2 real ones, and then there were 2 imaginary ones. So actually, he had 2. He could have had all 4 real ones, but he didn't. How many complex? Exactly 4. 2 of them were real, 2 were imaginary. State the complex zeros. Okay, here's the zeros. Negative 2, 1/3, 3i, and negative 3i. So these are the zeros. If it says state the zeros, you write x equals. If it says write it in factored form, you use the parentheses. And please read the directions carefully on the test so you know what kind of factoring to do. 2 days ago we were stopping, but now we're going to use imaginaries and go all the way. Okay, here's another type of problem. F of x equals 2x to the fourth. Okay, and it tells us it has the 0, negative 2i. Okay. How many zeros did they tell us? Actually, buy one, get one free. There's another one at positive 2i. So f of x, take a look at this, has 1, 2, 3, 4 sets of parentheses that it's going to get factored into. And how many of them do we already know? We already know 2 of them. So I'm going to fill in 2 of these parentheses already. X plus 2i, x minus 2i. So we already have half of the answer. We just need to find the other half of the answer. Okay, and I'm going to put a note here. Some people like to do synthetic division with imaginaries, but synthetic division with imaginaries is hard. Okay, it's really hard to do. There's a lot of like terms. It's really, really hard. So here's a much better way to do this. If I were to consider f of x as 2 sets of parentheses. So for example, if I put these 2 together and I put these 2 together, this would be the squared and the squared. So let's go ahead and FOIL this out. First is x squared. Outers and inners cancel, so this makes minus 4. When I say I squared, you say negative 1, so that's going to turn into a plus. Okay, so we already have half of it. Now let me say this a couple of times. F of x is something times something. F of x is this times this. This is the big F of x, and he is this quantity times this quantity. How do we find this? And if you need a hint, I could always show you this warm-up page. If you know one of the factors, that's right. Okay? You do long division. Do long division to find remaining factor. To find remaining factor. Do long division. Now it's been a while since we did long division, so I'm going to go ahead and walk you through the steps. First of all, you put f of x in the divide box, and don't forget your oxes. After the fourth comes the third powers. Okay, great. Plus 5x squared plus 20x minus 12. Okay, do long division. Put in oxes if you need them. This one did not need them. We're going to divide by x squared plus 4. Okay, you don't have to put oxes in the divisor. And how do you do long division? Well, you're going to compare the first one, x squared, compared to 2x to the fourth. So how many is he missing? He needs a 2x squared. Okay, after you find it, what you do is you multiply, okay, by both those terms. We're going to multiply. So 2x squared times x squared is 2x to the fourth, plus 8x squared. Oh, I know where to put 8x squared here with the squares, 8x squared. And then it's time for change. You have to change the signs to the opposite. Okay, let's go ahead and add the columns. The first one should definitely cancel. This one I'm just going to drop down. These add up to negative 3x squared. Let's drop down the rest of them. Plus 20x minus 12. Okay, step 1, good. Step 2, let's take a look at the first and the first. So what is he missing that this big one has? He's missing a 5 and an x, a positive 5x. And then it's time to multiply. 5x cubed plus 20x. Oh, let's put 20x here. And then it's time for change all the signs. The first one better cancel if you're doing it right. I'm going to drop down negative 3x squared. Another cancel. Drop down minus 12. And now it's time for the last matchup. X squared compared to negative 3x squared is missing negative 3. Okay, this should be the last one. Negative 3x squared minus 12. And our last change. Negatives get changed to positive. Cancel, cancel, 0. Okay, and here's the most important note you can write. Okay, must divide in evenly. It must divide in evenly. Because remember, something times something made the polynomial. If it doesn't go in evenly, you made a mistake somewhere. Okay, so now x squared plus 4, and this one was 2x squared plus 5x minus 3. So I found the other quadratic. A quadratic times the quadratic made the quartic. Okay, and now I can just go backwards here and factor this into 2x minus 1, x plus 3. All right, what does it say down here? Write f of x in factored form. Oh, you got it. F of x equals x plus 2i, x minus 2i, 2x minus 1, x plus 3. 2 of them were reals, 2 of them were imaginary. State the zeros. Okay. Negative 2i, x equals positive 2i. Buy one, get one free. X equals 1/2. X equals negative 3. Those are the complex zeros. Okay, let's do one more. Find the complex zeros and write it in factored form. Okay, but look at this hint. None of the PRZs work. So even if you made a nice long list of PRZs, none of them are going to work. We need to do a different approach here. Okay, but they did tell you one of the zeros. In fact, buy one, get one free. The other one is 1 minus I. Okay, so where's f of x? F of x is a 4th degree, so 1, 2, 3, 4. I know he has 4 sets of parentheses, and I already have 2 of the zeros. X minus 1 minus I, x minus 1 plus I. I just have to find 2 more. This is that same problem we just did. So actually, if we consider f of x, I know he's going to be a quadratic here, and then he's going to be a quadratic there. Okay? And now we're going to try multiplying this, maybe with the technique that I taught you the other day. So let's go ahead and try that. So what we're going to do is we're going to look at the thing they have in common as the a part, which is x minus 1. And the thing that they have in common for the b part is I. And so this problem is a minus b, and this factor here is a plus b. And so the answer down here is going to be the a thing squared, a squared, minus the b thing squared. Okay, so let's go ahead and write this down. F of x equals x squared minus 2x plus 1 minus, if I say I squared, that's negative 1. Change. So f of x is x squared minus 2x plus 2, and then there's another factor. So f of x is a 4th degree polynomial. He's got x squared here, and I know this is going to be x squared here. How do you find the other factor if you know what they make? Long division. So we're going to put the big f of x in the divide box here. 1x to the 4th plus 0x cubed plus 1x squared minus 2x plus 6. You have to have a column for everyone, so I added in some x's there. The divisor is this quadratic, x squared minus 2x plus 2 They never need oxes. And so we're going to look at the first thing and the first thing. He needs x squared. X squared times x squared is x to the fourth minus 2x cubed. Oh, good thing I had that column there for the cubics. Plus 2x squared. And it's time for change, change. Actually, change, change, change. Okay, your first column better cancel out or you're not doing it right. The second column is now 2x cubed minus x squared minus 2x plus a 6. Okay, it's time to compare the first term with the first term. He needs a 2 and an x, so plus 2x. I'm going to multiply 2x cubed minus 4x squared plus 4x. And it's time for my red pen. Change, change, change. First column cancels. 3x squared minus 6x plus a 6. And now it's time to compare again. This is going to be the last time. I can tell he's only missing a 3 plus 3. Make sure you finish it off because it has to make a 0. If it didn't, something went wrong, either here or maybe up here. 3x squared minus 6x plus 6. And when you change, 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 the remainder must be 0. Okay, please don't take your test, get something and say it doesn't work. Okay, it does work because it said it was a 0. So that means the quadratic here is x squared plus 2x plus 3. And then we can just go ahead and factor that into 2 parentheses. I don't think that does factor. Okay, if it doesn't factor, then I guess I'll just use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So, 2a, 2's a 1. X is negative 2 plus or minus the square root of 4 minus 12, negative 8. Now I'm going to simplify this into 2 terms. Negative 2 gets his own 2. And then, let's see, I had to poke an eye out. And radical 8 is 2 radical 2, so he gets his own denominator of 2. I like to separate, give them each, so the canceling works out nice. So x equals negative 1 plus or minus radical 2i. Look at that. So if we go all the way back up to the beginning, it's x plus 1 minus radical 2i, and x plus 1 plus radical 2i. There's no way that would have factored by hand. All 4 of the zeros are imaginary. This 4th degree polynomial opening up does not touch the x-axis at all. There's no actual real intercepts. They're all imaginary. Let's see down here, I think it says, write it in factored form and find the complex zeros. Okay, so the complex zeros are these 2 as well as 1 plus I, 1 minus I. Buy one, get one free. There's the complex zeros. And here is f of x in factored form. Okay, I can't wait to practice some of this tomorrow.